Good evening again, esteemed panelists, Dr. Ashok Puri, Dr. Muralidhar, uh, OEM Update colleagues, and attendees, industry stalwarts who are attending this webinar. Um, my presentation is fairly brief. It just looks at connecting the dots between manufacturing and digital manufacturing, and how digital manufacturing in its current sense will be able to, kind of reduce the gaps that exist in today's, or rather, it would address the gaps that exist in tooling manufacturing and tooling supply. So I'll just share my presentation to begin with. So I just thought I'll put in a few key facts before we, get into the topic of what I'm going to speak about today. A few snapshots and a highlight that I've put in here for your perusal. Uh, so the Indian tooling industry is roughly about 18.8, or can round it off to 19, roughly $19 billion. And it is expected to grow at a consistent rate of about 7.3 CAGR. And this is as per latest research. Nomura is part of it, and the Tagma, publishes as a source for this. And then this is a fairly decent number that I've also seen being validated by other critical OEMs in the region as well. So it is a well-known fact that the tooling industry is structural. I mean, it is a foundation, and it is very critical for the success of numerous uh, domains. Let's say, for example, aerospace, automotive, consumer goods, electronics, and so on. So, despite this growth that we have, roughly about 30 or 40% of the tooling that we consume is continues to be imported from countries such as China or South Korea, Taiwan, and the likes. So we also have to note that there is a distinct cost advantage that some of our neighboring countries enjoy. This has got to do with materials, availability of high quality steels. I shall not go into details in those in that domain, but it's suffice to say that there exists a cost disadvantage to tooling manufacturers in the country, and that has to be noted. And this is roughly about 14 to 17% in an average, tooling. You can consider a mold or a die set, and roughly between 14 to 20%, you can say, is a number. Um, the key facts, the key positives of our Indian manufacturing, of course, is that we have a robust and resilient MSME, presence. Is the backbone of our manufacturing industries. Of course, tooling also is a large part of it, and MSMEs continue to be the largest component of our tooling business. We have commercial tool rooms, and we have very small, uh, you know, um, 3 or 4 CNC machine kind of shops that also back up as tool rooms. So we have it's both organized as well as slightly unorganized in certain sectors, but nevertheless we have capacity and capability that is established. The challenges remain of the import side of things, the high value of raw materials, and also the lack of application of certain technology. This is again into very, if you look at the high cost toolings that we look at, there is certain gap that exists there as well. We compete very well with the low cost or the mid range kind of a tooling business, but then there exists a gap at the finer technology on top. There are uh, there are certain commercial tool rooms in India uh, that have competency which is at par with global standards, but by and large, the MSMEs lack these. Again, the Viksit Bharat and the manufacturing push that we've received in the past, um, close to beginning 2014 onwards, 2019 reinforcements, we can see that manufacturing has steadily increased, and also the dependency of that manufacturing on our own domestic tooling industry also is increasing. So having said this, let us look at the context of how digital manufacturing, the CAM part of it, is able to add positively to the benefits of what we have seen in the previous slide. So if you look at a snapshot of this slide here, it just covers what a tooling company or tooling industry expects from a CAM software or a partner. It's divided into two aspects. One is got to do with the aspects of the technology itself, which is related to profitability, which is related to reliability, which is related to productivity and best practices. But also there's a human element, which again overlaps between reliability, timely support, best practices, and making the tool versatile, more versatile. So the point that I'm trying to make here is that yesteryears, we could look at a CAM software as just a standalone island tool. You would receive some data, you would create some toolpath, and then you would pass it on to manufacturing. So we are evolving from programming to orchestration. So this is what I want to establish here. So there was decades, CAM was only about toolpaths. Now it's about process. It's about people. It's about machines. It's about taking data from what it was envisioned to where it needs to reach at a manufacturing stage, and then further validated after that it conforms to the standards of which it was manufactured for. Right. So softwares like Mastercam, of course, sit at the center of this evolution. They transform the standalone programming that we've seen into a connected manufacturing platform or manufacturing intelligent platform. So the flow that you see is going from a CAM to an integrated CAM to an intelligent CAM to a connected manufacturing ecosystem. Right. So whether it's a small MSME that we speak of today, or whether it is a large commercial tool room, we are all, whether we like it or not, have moved towards connected manufacturing. You have upstream, supply chains, you have downstream supply chains, and whatever position that the manufacturer or the tooling person or the tooling organization lies in this ecosystem, they have to respect that there's a process before and there will be a process after. So that needs to be considered. And therefore, certain capabilities are become necessary. For example, like being Industry 4 and Industry 5 ready. And this snapshot here talks about that, about the software being a tool to do what is needed, but also to encourage partnership with machine tool manufacturers, because they are the ones who are bringing in new machine tools every year. The tooling partners who are coming up with new tooling data, new tooling innovations every year. And all of these is now digitized. They're no longer, paper knowledge books. They're all put onto the internet, or they are a part of the AI agentic systems that most of these people have built and embedded into their systems. And somehow the tooling manufacturer needs to be able to have touch points with all of these various connectors. And this slide speaks about that. And why are we doing that? We are doing that so that it becomes flexible for a system to be used across a host of end-use machines. So whether it is CNC machines, whether it is 3D printers, or the hybrid machines, subtractive and additive manufacturing kind of machines, or even industrial robots, for example. So it enables a seamless connectivity to all of that. Now, while the technology aspect is important, it is also very vital that we bring in a leadership, whether it is from the software side, whether it is from the tooling side, or whether it is from the the machine tool side, the OEM side, to try and bring skilling into the ecosystem. Now, what is skilling? Skilling is nothing but enabling modern skills along with historic knowledge, so that these people, the young engineers or young technicians, are able to then bring these theoretical and practical knowledge into physical and practical productivity that everyone expects in the industry. So the CAM operators, therefore, are no longer just, they don't just punch numbers on the machine. They are now set to become data interpreters. They are becoming decision makers on the shop floor itself for a variety of reasons. And this is possible through process and automation, building intelligence into the system. There are API integrations, the connectivity between software, hardware, and tooling, and the advent of Copilot and AI-driven tools they're only able to enhance these. Now, let's take a look at a small example here. I won't play the entire video.
Manufacturing industry is at a portion of Operation 3. And I'm asking Mastercam, the manufacturing.
So I'll start from the middle here. So this is nothing but an interface of a CAM system. In this case, it's Mastercam, and there's an open model on the screen, and there are certain operations on the left side that are seen. Now, what you see on the right side is model innovation. That is Copilot being installed within the CAM system. And it is not there just for the purpose of understanding the software, or it's not a help document, but rather it is an interactive tool that is context aware of what's happening on the screen, and the user is able to interact with it. Through commands, whether it is texted or spoken, the information is communicated. I'll show you how the future is going to look like. I'll skip the other part.
Hey, Mastercam, open linking parameters for operation 15. Drop the depth 5 thousandths, save, and regenerate.
You can see that the power of embedding AI systems. I was speaking to a skilling authority just about a couple of months back, and the first thing that they ask is, the people that we are working, the students that we are working with are in rural areas, so English perhaps is not their language at all. They don't even know the language. The language that they use is something of a dialect of their local language. So with the advent of systems like these, skilling also becomes very easy because translation happens automatically through that system. So, the language barrier that existed until recently of communicating technology to technicians and engineers is no longer a barrier. And therefore, what we are able to look at in this whole ecosystem when we are looking at a digital transformation is that we are bridging the skill gap. We are transitioning from a trial and error to a first part, right part philosophy or mentality. This is very important, right? And maximizing ROI on high precision hardware. Now, the moment you go on making trials for the same part so that you are able to then, get the best output of it, you're wasting valuable time on the CNC machine. Now, instead of that, if you're able to take it offline, do run iterations on the software, use AI-based tools to optimize it, and then run a fine-tuned program on the machine that is able to increase your ROI on that hardware. And finally, we also look at enhancing the tool life in a cost-sensitive market, because most of the manufacturers feel that consumables add a lot of burden on their operational expense. But unfortunately, that's not the case. If you do an analysis, it is the process where you can save a large amount of money than just by saving in consumables. Although it is possible to save on consumables as well. And therefore, by integrating these standardizations, whether it is feature-based machining or AI tools, and then scaling productivity via these agentic workflow automation systems, we will then be able to bridge that gap of 14 to 20% that we spoke of, the gap that we have with our neighbors in terms of tooling competitiveness. We can then bring that down to a marginal number, or if not completely avoid it. And that was my submission. Thank you very much for your patient listening. This is a snapshot of who we are and what our reputation is. Thank you for your time.